Yeah. What is motion? My question is simple. What is motion?
Sir, motion.
Yeah.
Sir, a body is said to be in motion when its position changes continuously.
Continuously
With,
with time. Means
yes, sir.
that with respect to time, right?
Yes, sir. With respect to a stationary object taken as reference point.
Okay, that's good. That's good. You understand a lot. So motion is change in position of an object, okay, with respect to time uh, or with respect to frame of reference, right? So
Yes,
there
sir.
are two type of motion generally. One is uniform motion and another one is non-uniform motion, right? The
Yes, sir.
trajectory of motion may be the different as well. So first of all, I will choose the red pen. That's it's good. The motion. Motion. Motion is basically change in position of an object. Change in position of an object. Of an object with respect to time. With respect to time
Right.
in the given frame of reference. In the given frame of reference. A screen is visible.
Yes, sir.
A font is also
Yes.
font size of letters.
Yes, sir.
I think now it will be bit good. So how we will see and how we will measure the motion. Suppose this is an axis called X and this is an axis called Y. Okay. So basically this X is nothing but time. Okay. So in this axis we are putting time and this Y axis we are putting distance. Okay.
Yes.
So if we draw a line like this, okay, so we see that with position, with time, the position of particle is changing, or we are measuring it from origin. Okay, so this is origin. So we have to fix two things. First is frame of reference. What is frame of reference?
Sir, I don't know.
Okay, frame of reference, for example, if we are doing any calculation sitting in our lab, that lab that is attached with earth, then it will be said a frame of reference. Okay. So a system which is stationary, a point of calculation, we say that a point of observation, a point of observation which is non accelerating. Okay. A point of object which is not accelerating or non-accelerating. You may go with that. For example, a point attached in lab. A point of observation on Earth's surface. Earth surface. So we see that, we assume that Earth's surface is not accelerating, right?
Yes,
Got the
sir.
point? What do we mean by accelerating? What do we mean by accelerating? If we will observe anything sitting in a boat or in a car, okay, so in that case, that point of reference will be not the actual point of reference. So if we want to observe anything, we have to sit calm somewhere, which is stationary. Because if you are sitting in some accelerating car or somewhere, then using Newton's law of motion will be complicated. Okay. So
Okay, sir.
avoid those complexity. We say that and that reference frame is non-accelerating, right? So now I have a question. You have to tell your friend address, okay, over the phone. You have to tell your friend about your current address, about your current address. Okay. What quantity you will inform him? You understand Hindi?
Yes, sir.
Okay, so from which part of India? I think you are from Indian subcontinent.
Yes, sir.
Which part?
Hyderabad.
Okay, Hyderabad. So now you have position that you are calling a friend or you are telling your location, okay, or your coordinate. What point you will tell him? Building number, room number, street number. What else you will say to him?
So name of street and
The question is clear to you?
yes, sir.
So first of all, you will tell him about the location. Location. It may be a street number, okay, flat number, floor number, or something. The next thing you have to tell him about the time. Is telling him time is necessary or not?
So not necessary.
Not necessary. How confident you are? Suppose, what is your school time in morning?
8 o'clock, 8:30.
8:30. Okay, 8:30. And you are punctual to your schools? Your school?
Yes, sir.
Okay, so you inform your friend that you will be a street number X and flat number Y. Okay, before 8 and 8:30, you call him in morning and you say it like that. Okay, and he came to you by 9:30. Will you be find over here? Will he
No,
find you? Huh?
no, sir.
No, sir. Okay, so what we are missing?
Time.
We are missing the time. That's why when we were defining the motion, okay, we use the with respect to time. Got the point?
Yes, sir.
So locate your coordinate. You have to give the position, comma, time. These two parameters are necessary to locate the position. Got my point?
Yes, sir.
It's clear?
Yes, sir.
So how you see the definition of motion now? It must be frame of reference, that which floor at what time. So these two are included. We measure the speed or motion with respect to time. We say now 5 km per hour. 5 km per hour. So this is measure of motion, right?
Yes, sir.
So here is two quantity, kilometer and hour. We can't only say 5 km is a motion. It's not a motion, it's only the distance. So motion includes the dimensionality as kilometer per hour. Right?
Yes, sir.
What what else about the frame of reference? Suppose you are sitting in a moving train. You are sitting in a moving train. Train is moving with a particular speed. Suppose is a speed. Speed. There are people standing on the ground. Okay, this is the ground, earth, and this is your rail track. So if rail is going forward, right side, we see that these people on the floor, on the earth is moving toward left side. This happens,
Yes, sir.
and this guy from the earth surface will see that you people are moving right side.
Yes.
We see if we are sitting in the train that these people are going backward, and these people sees that we are moving forward. So there are two contradictory statement. You got my point?
Yes, sir.
So why this contradiction comes? What's the reason? Any reason? Any reason? Do you feel that is because of some reason or something?
Yes, sir. Because of motion.
So this is a bit called relative motion. Okay. We are doing motion with respect to earth. Okay. In relation with earth. So if we are moving, then the same thing is happening with earth. So this is the concept of relative motion. So you got what is relative motion?
Yes, sir. I got it.
Okay. So these were the type of motion. Then we again have a uniform motion. Uniform motion. Okay. What do we mean by uniform motion? Is the summary of the class. So we will be joining newest old students by 9:30. So before that, I'm trying to connect you with some important topic. So what is uniform motion? Are you aware of it? What is non-uniform motion? Non-uniform motion. You don't know?
Sir, I
Okay. Do you know what is displacement?
yes, sir.
What is displacement?
Yes, ma'am. This,
And
short
what is,
distance,
yeah, you go ahead. And what is distance?
distance is how much travel by us. How much
So,
distance traveled by.
yes, right. Good. So displacement is actually the shortest distance between 2 points, right?
Yes, sir.
So you may write it down, the displacement called the shortest distance between 2 points. Let me write it for you, if I get time. Displacement. Shortest distance is short, shortest distance uh, between between 2 points. For example, we have location A here and location B here. Okay, if we started, we are going straight, it will be the shortest distance. Okay, this will call the displacement. This is a vector quantity. What is vector quantity? What is vector? Do you know what is vector?
Which has magnitude and direction.
Oh, very good. It has magnitude. It has magnitude and direction. What we mean by magnitude? Magnitude and direction. What does it mean? What we mean by magnitude and direction? So its magnitude maybe if we start from, this is origin, the point of reference, and this is 1, this is 2, and this is 3 in
Yes.
kilometers. So the magnitude is the 3 kilometer. So magnitude is equal to 3 kilometer. And if we see what is direction, so if we'll draw like that, this is north, this is south, this is east, and this is west, right?
Yes, sir.
So we are going in this direction. So we are going toward east. So direction east. So this correspond to direction. So is clear what do we mean by magnitude and direction?
Yes, sir.
Okay. So and will you note it or take the screenshot? Whatever is feasible to
I am
you, you
noting.
may. Okay, so just note it
Add
down.
screenshots and like.
Okay. So SI unit will be what? Meter. Meter. METER meter. And we will write it with a small m. If you are done, let me know.
Yes, sir. I've done.
Okay. So this one another uh, what we call them, these are the physical quantities. Okay. These are the physical quantities. By physical quantity, what do we mean? Do you know what is the meaning of this physical quantities in
Quantity
physics?
that can be measured.
Very good, very good. So the distance is one of the physical quantities. Similarly, we have distance. So as we discuss about the displacement, distance is loosely speaking, that is the distance covered by any object. It's not the shortest or it may be the longest. Okay. Either it will be shortest or it will be longest. There are no restrictions. So distance. Distance. Distance is a scalar quantity. It has only direction. Sorry, it has only magnitude. Magnitude. Its SI unit is also the meter, which we say by a small m. Okay. And one more quantity is that distance will be always greater and equal to displacement. Right? Got the point? This is always the positive quantities. Distance is positive quantities as well. Is positive quantities, and displacement maybe zero, positive and negative as well, right?
Right.
This will be positive, negative, and zero as well. This is positive quantity. Distance can be zero if we are not moving. We are not covering the distance in that sense. But displacement, suppose you are moving on a circular track. Okay. And you started from this point and you reach back again to this point. So there the displacement is equal to zero. Daily you used to walk from home to school, home to school, and then school to home. So your displacement is zero. Got the point?
Yes, sir.
So I think it's clear again.
Yes, sir.
Any doubt till the discussion? Any doubt? No doubt? Everything is smooth?
No doubt.
Okay. So I asked you what is uniform motion. Now I am asking you what is uniform motion. Will you tell me what is uniform motion? Do you watch cricket?
Yes, sir.
So have you heard about the average run rate?
No, sir.
Okay, leave it. So when we say about that run rate, average run rate, we mean that for the, what can you say, first power play, the early 4 or 5 hours, someone says or announce that the average run rate is 20 runs or 30 runs or whatever it is. I also don't watch cricket much, so I'm not bit aware of that as well. So in that case, it's not necessary that in each and every hour, the scored run is equal. Okay. Non-uniform, we are discussing first. Non-uniform motion. Non-uniform motion means that in first hour, he might have scored 7 runs. In second hour, this is over. This is runs. Maybe 8 runs. In third hour, 13, 17 runs may be possible. And in fourth hour, there is 2 runs. So what What the average means? We will add all and divide by 4, right? This will come as average. But we see that there is no equal runs in each hour. There is a different run in each hour. So it means that if you are covering a distance, this is time and this is distance. We may say it x. If you are doing like that, so it means that we are not uh, tracing the equal area in equal time. No equal distance in equal time interval. Equal time interval. Time interval means that you started from your home to school in early 5 minutes. You were walking gently, early 5 minutes. Then you realize you are being late. So you started your speed. Now you are moving with 7 km/h. Now you met your another friend and then you again got some speed. Now it's 8. So finally you reached your school in the given time, but you see that you are not covering the equal distance in equal time. Okay, so this is your non-uniform motion. For simplicity, I'm just telling you the uniform motion is what? Uniform motion. Uniform motion. Can you guess what will be the uniform motion? With definition to non-uniform motion, can you guess what could be the uniform motion?
They're going straight. Right?
If you will say a straight line, this is one axis, this is another axis. This is again the time axis, and this is position axis X. So if we are going with uniform motion, this will be a straight line. That's what you want to say,
Yes.
right?
Yes.
So if you will see that this is the time interval. Okay, so and again you will draw this as this like. So you will find that in equal time interval, this is the time interval, you have traveled the equal distance, this one. And again, the next time interval, this is really big. Okay, somewhere here it might be. So in equal time interval, we cover the equal distance. So if we do equal, if we cover the equal distance in equal time interval, then it will be uniform motions, right? Got the
Yes, sir.
point? So we have to stop here for a while. Hello, the newcomer, uh, Abdul Jabbar, right? Munir. Munir is the old one. Jabbar, that Munir is the new friend with us. So, Jabbar, what did we study last time? Do you remember?
No, sir.
Sorry,
No, sir.
you were in last class.
No, sir.
So you are new as well.
Yes, sir.
Okay, so actually admin told me that there will be two new students, so you have to start little bit early. So I started with Munir around 9 o'clock and we discussed little bit, right? So
Yes, sir.
it's this time it's not possible to repeat those things again. I'm sorry, we'll do it for you later, right? Any problem? We only discussed the motion, definition of vector and scalar, definition of a scalar and sorry, for yeah, uniform motion and non-uniform motion. We discussed a little bit about the speed and its relation with displacement. Nothing more, right?
Yes, sir.
So So Riaz, you were in last class, right? Did you? So anyone attended the last class from today's room? Any of you attended the class last time when we discussed about the equation of motion, uh, graphical representation of equation of motion? We derived some equation of motion as well. Any of you attended that class? Do you know what is graphical representation of equation of motion? Any of you? Yes, you are watching on the phone, right? Riaz, you are watching on the phone, right? Munir, concept till this point is clear to you? Any confusion?
No, sir.
Okay. So there are further uniform, non-uniform motion. There are some circular motion as well. Okay. Zigzag motion, motion in a straight line. So these are the trajectories of motion. Uniform and non-uniform motion is in terms of speed. If you will take the time, position versus time, if you will take the slope, uh, x over t, this is the delta x. This is the delta t. This is delta x. Okay, this is delta x over delta t. We will get velocity, right? So uniform and non-uniform motion is term of speed or velocity. In term of uh, trajectory, there is some circular motion as well, as the moon revolve around our earth or other planets do. So this is the circular motion. Okay. There are some rectilinear motion as well. Rectilinear means a motion in one direction. Motion in one direction or two directions or any directions. Okay. In three direction as well. Then there is again the motion of fly. There's no a fixed trajectory for it. So these are the trajectories of motion as well. Okay. So if we will get time, we will do it in a sequence or one by one. So I only did so you can catch the continuous class. So still I have to get response from the guy who had presented today. So any of you were present in the last class?
No.
So Munir, you are the new.
Yes, sir.
What about Riaz and Jabbar?
Yes, sir, I was there in the last class.
So you were there in last class. So we discussed about the graphical representation of motion. Remember?
Yes, sir.
Okay, we already did the laws of motions. So we were doing graphical representation of motion, or we did it, right? We derived some relation as well. You remember?
Yes, sir.
We find the area of this shaded part, and we said that area under distance time graph is what? Did we say something like that? We only find the area of this shaded part. Okay, half into b into h. This. See, Munir, this is the graph of uniform motion or speed. So if we will see that there is equal distance in equal interval of time.
Yes.
Riaz, do you remember what is definition of uniform motion?
Like when a, when a particle when a
Yeah,
particle
good.
covers equal distance in equal amount of time.
Equal amount of time. Okay. So if we just I'm recapping it in a minutes. Okay. So if we notice that it 20 time interval and in 40 time interval. Okay, this is the 40 time interval. So this is the time interval and this is the distance, right? Y-axis there is distance and in x-axis there is time. So again, if we will match this line somehow, okay, and this, if we see this again, so see this length, uh, this is over here. So we may use like this. So this length and this length are equal. Okay, similarly, if we'll proceed from here, this is the 60, and we just proceed and see this. So we will find again that this line, and this line are equal. So if you wanna see, you may draw you time is distance over change in distance over change in time. So the slope will be always equal. If you wanna see, so in first from this 20 minutes, how much distance we have covered? Any idea? Just let me clean the graph. In first 20 minutes, we are approximately over here, right?
Yes.
Is screen visible to you? Or I'm just beating around the
Sir.
bush? In first time interval, we are over here, right? And this stands for 11. Okay. So from 0 to 11 minus 0 will be 11 minus 0 will be 11. And then this time interval is 20. Okay, in first interval of time. So if we will again move from this point to this point, okay, this point, see. So I think this is this point and this is the this point, right? This point. So how much distance is being covered is how many division? 1, 2, 3, 4, 5 divisions. So it's not 11, sorry. It's 1, 2, 3, 4, 5 division, 2, 4, 6, 2, 4, 6, 8, 10, 2, 4. So it is 14, right? Because 2 division equal 5 division equal to 10. So is the marked by 2 division 2, 4, 6, 8, 10. So again, if we mark 2, 4, 6, 8, 10, 12, and 14. So again, in the next time interval is 14 over 20 again. Did you counted it? If you will count from here to here, you will find the 14 interval, right? So if you will do the same for this point, you will again find the same thing. Okay. So 2, 4, 6, 8, 12. 12 is 14. So 2, 4, 6, 8, 12 is 12, right? So actually there may be some confusion. So we see that equal amount of distance in equal time interval, right? Is clear?
Yes, sir.
So there is equal amount of distance traveled in equal time interval. So Rumaiza, you were in last class, right?
Yes, sir.
So we already discussed about the uniform motion and non-uniform motion, right?
Yes, sir.
We also derive some relation
Yes, sir.
Relation of motion S is equal to ut,
Yes, sir.
v is equal to ut plus half of at square.
Yes, sir.
What else? What else? These were the equation, right?
Yes, sir.
So Rumeza, you remember how to calculate these relations, or should I brief? Should I
Sir,
brief?
can you? Yes, sir.
Okay, so it will be helpful for the new students as well. So we are here with velocity time graph. So I'll do this equation. First, I'll do this equation. Okay. So how to find the area of this shaded figure? Area of ABCD, right? ABCD, right? What is the formula to find the area of this rectangle?
Area is length into breadth.
Okay, so we may say this is length,
Yes, sir.
right? And this is breadth. No problem?
Yes, sir.
Clear to everyone? So length is given at time. So I will just say it is time, not T2 minus T1 or T3 minus T1. And this is velocity. So we say it velocity. So we may say that area under velocity time graph D gives displacements. Area under velocity time graph gives displacements. So how it gives displacements? So see, here is time, or how we define velocity? Distance over time. This is definition of velocity, right?
Yes, sir.
So if we will cancel it, what we are left with? We are left with displacement, right? X is displacement. So area under velocity time graph give displacement. So we may write this as equal to S is equal to Vt. We got one relation. It's very basic relation. Everyone got this calculation?
Yes, sir.
What about other guys? They are not responding.
Yes, sir.
They are just sitting in the circus and just enjoying. What about Jabbar, Riaz, Munir?
Yes, I.
You got na?
Yes,
This is a
sir.
basic calculation. So if you got this, could you do it for me? This is the bit complex figure. So can you find the area of A, B, C, D, E? Okay. A, B, C, D, E. How we will find the area of this shaded figure? Rumeza, do you remember?
Yes, sir. Area of square rectangle plus area of triangle.
Area of, sorry, area, I attend the A of it. Area of A, B, C, D plus area of A, D, E. So guys, tell me what is area of A, B, C, D? Tell me what is area of A, B, C, D? Anyone? What is area of A, B, C, D? These are all latecomers. Who has entered now?
Sir, Riyadh.
Riyaz. Okay, so can you tell me what is area of ABCD? Rumaza, do you remember?
So half into T2 minus T1 into V2 minus V1 plus T2 minus T1 into V1 minus the initial velocity V0.
So dear, I only asked what is area of ABCD. You just only tell me, Rumaza, what is area of ABCD, this part. We may say that this is a rectangle or whatever it is. So just tell me what is area of rectangle,
Length into breadth.
length into breadth, right? Everyone agree with her?
Yes, sir.
Okay, so we may say that this length is T. I'm just doing a simplified calculation. This length is T, right?
D. Yes,
So
sir.
this is equal to T2 minus T1. So we will, for simplicity, we are only saying it T. This is length or this is breadth. Okay. So on this axis, we have velocity. Are you guys there? There was power cut, so
Yes.
I apologize for that. So I'm audible again.
Yes, sir.
So
Yes, sir.
I'm sharing the screen as well. And that's my video. Participant can see me, but I can't see the participant. So the length is t, and we may say that this is 0. So we may say this is 0. Okay, the velocity, initial velocity is 0. We may say it v1, or here it will be v2. So this is connected with this axis. This is v1. Okay, and this is v2, right?
Yeah.
So we may write it as v1. Got the point? Now it's time to define the area of this triangle. So guys, what the area of triangle is? What the formula of it? What is the formula for triangle? Area of triangle.
Then
So what the area of triangle is? Will you tell me what the area of triangle? I'm audible.
yes, sir.
So what is area of triangle? You guys didn't figure it out. Half into base into height. So this is base only, na? A to D is the base, which is equal to what? T is barabar. Area of triangle half into base into height. Height will be what? Height will be this length, right? So we may write it v2 minus v1, right? And how we define the acceleration? A is equal to v2 minus v1 over t, right? This way we defined acceleration. Everyone agree? Everyone agrees? Rumaza,
Yes, sir.
do you agree that we define Rumaza is not here, na? She left, I think, because of network issues. So, are you aware? Rumaza is back. Rumaza. So, Rumaza, how you? Okay, you are back. Rumaza, I'm audible.
Yes, sir.
Okay, so what is area of triangle? Jabbar, Munir, Riaz. What's the area of triangle? Half into base into height. So this is base and this is height. So we retain it as half of t into v2 minus v1, right? And we know that this is nothing. This may be written in the term of v2 minus v1 is equal to acceleration into time. We remember measure from last class as well.
Yes, sir.
So this will be v1 t plus half. This is t, and again we will write v2 minus v1 is equal to 80. So this will be v1t plus half of at square. And this is displacement area under velocity time graph gives what acceleration. Sorry, displacement. So S is equal to ut plus half of at square. Clear?
Yes, sir.
So we derive two relations. Actually, till standard 9, we don't have to worry about the derivation of the formulas. Okay. But still we are doing it because it's simple. So we derive these two relations. That first relation was S is equal to V into T. Another relation is S is equal to UVT plus half of at square, right? So here we may say that this V is initial velocity. So we suffix it with ut. It depends upon us. Okay, what we wanna write it. We wanna write it as v naught. If we wish, we may write it as ut. U into t, and here u into t plus half of at square. Is is clear to you, Rumeza, again?
Yes, sir.
Any confusion?
No, sir.
And another definition, we just write it. V square is equal to u square plus 2a into s, where a is acceleration, acceleration, and s is displacement or distance, displacement, and u naught is initial velocity, initial velocity, and what v is final velocity, right?
Yes, sir.
Any confusion to Riyaz, Rumeza, Jabbar, anyone?
No, sir.
So is crystal clear to you guys? We too can derive the third relation as well. So I told you that these derivation is not the part of our syllabus in CRT, but still there might be in some your own syllabus of the schools or something. So we derive. So we are leaving third relation as it. So we are not bothered about that. So it's clear to everyone what does SVTA stands for? It's clear to everyone?
Yes, sir.
Yes.
Okay. Rameza, now I think you will be keeping everything on your tips. So those were the equation of motion. You may write the definition of equation of motion. When an object moves along a straight line with uniform acceleration. Condition is always uniform acceleration. Okay. So the equation we have derived just before is true only when acceleration is uniform. What does we mean by acceleration is uniform? That acceleration is not changing with time. Uniform acceleration means acceleration is not changing with time. Not changing with time. Clear to everyone?
Yes,
Yes, sir.
sir.
Okay, you may write it down or take the screenshot. It is possible to relate its velocity, acceleration during the motion, and distance covered by it in a certain time interval by a set of equations known as equation of motion. So we derived already two relation, and third one we stated as it. Clear? This was just repetition of last class.
Yes.
So pardon me, Rumeza. And Rumeza, we solved this question as well, right?
No, no, sir.
Remember? Huh? Remember or not?
Yes, sir. Yes, yes. Yes.
Okay. So will you do it for me today? Riaz and other guy, Jabbar, Munir. Are you catching?
Yes, sir.
Munir, are you catching? You are catching or not?
Yes, sir.
Or it bit fast? It bit fast or slow? No matter you do it this question again. Okay. Do it fast. Munir, if you have any problem, you may ask. Okay, no problem. So you try this question.
Okay, sir. Me?
Okay, try this question. So today, Romeza, I will send some different assignments. Okay. So did you solve the assignment what we forwarded to you? Those for those guys who were present in the last class. You didn't, Romeza, you didn't submitted the assignment, right? I only got one assignment from Abir. Abir is from this class or some another class?
Sir, I submitted the
No,
assignment.
but I didn't get.
Maybe I did not win, sir. I'll send it again.
Maybe I got assignment from some another student, but not from you. That's the thing. I don't know why. I don't know why I didn't get your assignments. So you did all the questions what we provided to you?
No, sir. The last one I did not get because I was out of station that time.
So there's no problem with concept or content. You couldn't try that. That's the reason.
Yes, sir.
Okay, so better you try that question right now. Okay.
Okay, sir.
And if you feel some problem, you ask me. So the
Yes, sir.
rest of the guy who didn't solve this question, try it. It's for new as well.
Okay, sir.
So Munir, you got the answer.
No, sir.
What's the problem? First of all, write all the given information. So a train started from rest. From
Sir,
rest
I'm done.
means you are done.
Yes, sir.
So how will you show me? What what could be the medium?
I can say it to you, sir.
How you have to send the admin, then I will get that. How will you send it to me? I can't share my number actually. You forward to admin and I will get, I think, from them.
Okay, sir.
I don't know what happening here is third time the power has been cut off. And unfortunately, I don't have much mobile data as well. It's too much painful. So Munir, you couldn't do this. So a train start from rest means that, where is my pen? Okay, so a train start from rest. So initial velocity is 0. Attains a velocity means V you have 72 kilometer per hour and time is 5 minutes. T is 5 minutes. So it will be 5 minutes. So 5 into 60 means that seconds. So 300 seconds. It's clear? It will be 72 into 1000 time divided by 36. So 20 and this will be 5 by 18. So it will be 20 meter per second, right?
Yes, sir.
So we got two information. So assuming acceleration is uniform means A0, find the acceleration. So we have to find the acceleration. So we already know what the formula for acceleration is.
A equals V minus U by T.
A is equal to V minus U by T. So we know V is 20 meter per second. So 20
20 minus
initial
0
is
by
0.
100.
Oh my God, 100 or 300?
300.
Yes, 300. So from here we will get
1 by
20.
15 meter per second square.
Very good. 300. So it will be 1 by 15 meter per second square. Per second square. Yeah, 1 by 15 meter per second square. This calculation is okay to everyone.
Yes, sir.
So now the another question is the distance traveled by the train for attaining this velocity. S is equal to ut plus half of at square. Can we use this relation?
Yes, sir.
So it already says that initial velocity is 0. So we will give it the value 0. 0 into t is 0. So here we have half. We already got acceleration 1 over 15. And time is how much? 300 seconds into 300 seconds. So I'm running out of a space. So here will be 300. Again, here will be 300. So now you have to solve it. This is 2 times, so 150, right? And then it will be in 100 times. So again, if we will cross it, so it will be how much? 3 into 10 to the power of 4, right?
Yes,
This
sir.
much meter. So if we'll change that, this will be 30 kilometer. I'm sorry, it's the fourth time power is cut. Okay, guys.
Yes, sir.
So is this uh, calculation clear to Riaz, Munir, Jabbar,
Yes, sir.
everyone?
Yes, sir.
Yes, sir.
So there are a few questions. Kindly take the screenshot for this as well. Take the screenshot. 1, 2, 3. Okay. So now another question. Take a screenshot. 1, 2, 3.